Momentum. Now momentum is a property of moving objects. P equals m times v. There's a triangle. Where P equals momentum, this is kilogram meters per second, m is mass, always in kilograms, and v is velocity in meters per second. The greater the velocity, the greater the momentum, and the greater the mass, the greater the momentum. So, exam questions will ask you about momentum in an event, and an event, in this case, means either a collision or an explosion. Now, the key thing to remember is that total momentum is conserved when no resultant force acts upon the body. So this means that in a car collision with another vehicle, the total momentum before the event is equal to the total momentum after the event. Whatever you work it out to be before the event, it's got to equal the same after the event. So here we've got a collision. We've got the blue car going into the back of the red car. The red car's stationary. The blue car is travelling at 15 meters per second and it has a mass of 500 kilograms. The stationary vehicle, the red one, has a mass of 800 kilograms. Now after collision they both move off. At what velocity? So where do you start with that? Well, the first thing to do is calculate the total momentum before the collision. Now remember, momentum, P equals m times v, mass times velocity. So the mass of the blue car is 500 and his velocity was 15 meters per second. So momentum of the blue car was 7,500 kilogram meters per second. The red car had a mass of 800 kilograms but was stationary, so had no velocity. So his momentum was 0 kilogram meters per second. So the total momentum before the collision was 7,500 plus nothing, which is 7,500 kilogram meters per second. Now you have to work out what happens after the collision. Now remember, the total amount of momentum is the same after the collision, but it's shared between the two vehicles. So the total amount of momentum after the collision is 7,500 kilogram meters per second. Now the total mass of the two cars is 500 plus 800, which is 1,300 kilograms. You can work out the velocity. Velocity is momentum divided by mass. 7,500 divided by 1,300 is 5.8 meters per second, to two significant figures. Explosions. Now in explosions, fragments of debris are flung apart. So do they all travel in the same distance and in the same direction? Now in this example, two pieces of debris were flung apart in an explosion. One piece had a mass of 0.2 kilograms and travelled at 5 meters per second, and the other had a mass of 0.4 kilograms and travelled in the opposite direction. How fast did the larger piece travel? Now hopefully when you read through the answer to this it'll be explanatory enough, but just remember, momentum is conserved. Now before an explosion there's no momentum because all objects are stationary. So the momentum of any scattered debris must cancel each other out so that the total momentum is also 0. So just remember that and try and have a go at calculating it for yourself.